first problem we're going to look at is, what if I want to remove all instances of a particular element from the list and return a new list? So obviously you don't want to use the remove method because that seems a little redundant. So let's see if we can define this. So with many list processing operations using list methods, you usually want to start off with an empty list, because the way I'm going to think about removing things is I'm going to add everything that is not the removed element, the element I want to remove. So that's in a way the same thing as removing that element. So that what I'm going to do is I'm going to define a new list being the empty list. And then for every item in my original list, if the item is not the element I want to remove, that means that it can be added to the list. So I'm going to basically take this new list and I'm going to append the item. And then at the end, I'm just going to return my new list. So let's test this to make sure this works. And it works. So this kind of structure that you see, where I initialize a new list, I iterate through something, and then I add things to a list, that's a structure that's going to be very common in all of these list processing operations involving the append method. Alright, let's look at another example. And I encourage you to pause the video and as always, stop and see if you can figure these out on your own. So here we want to return a list with all duplicate elements removed from the list. So how does that work? So here we have several duplicate elements, and we return the set of all unique elements in this list. So, and in this case, we don't have any duplicates, we return the original list. So how does this work? Well, one thing I can do is I can start off with an empty list, and what I'm going to do is I'm going to iterate through my list. So for element in my list, I'm going to check that, first of all, this element shouldn't be in the new list. Because if it is in the new list, then I know it's a duplicate and I don't need to add it. So how do I take in this logic? If the element is not in my new list, I want to basically add it to the new list. And that's actually all this is. So, and then at the end, we just return the new list. So let's make sure this works. And it works. So again, we have the same idea. We initialize a new list being empty, and then we go through our original list, and then we have a condition, and then we append the element to the list. So this is going to be very common with these type of problems. All right. Now the next problem we have, we want to return a reversed version of the original list without using list : -1. Okay. So remember, we've defined a reverse function before, but with that reverse function, we were mutating it. Now we want to return a new list that is a reverse version of this. So here, notice that it actually returns the new list reversed. So how do we do this? Well, we have to first start with the new list. And the process, this can actually be a little more intuitive than the previous one, because how do we reverse something? We take it from the last index first, and then go all the way into the first index. So I'm just going to have an index, basically, and I'm going to start that off at the last index. So what's the last index of a list? It's the length of the list -1. And then while it's the case that the index is greater than 0 or equal to 0, because once I reach 0, I know I'm done, I need to add this element to my new list, and then, oh wait, I shouldn't append new list, my bad. So how do I access the element? I basically need to get my list at the appropriate index. So this is the element of the list, and I add that to the new list, and then of course I can't forget that I need to decrement the index, because I'm going from the back to the front. And then from here, I return the new list. Alright, so let's see what happens. It passed. So this is how we reverse a list without mutating it. Okay, so now let's go back. So again, I encourage you to play around with these examples of the many other list methods as well, but I do want to talk a little bit about some special notes about list methods, because there are some little tricks. The append method always returns none. So don't expect the append method to return a list with the element added. Okay, so this is very important. It trips up a lot of people. Also, the pop element doesn't return that. It actually removes the item at the ith index and then returns it. Okay, and if you call pop with no arguments, it automatically removes and returns the last element in the list. And then also, one thing to never, ever, ever do is remove elements from a list while iterating through it. And some crazy stuff happens. And actually, I'm going to show you an example of this. So if I want to ever define a crazy clear function, so I want to basically create, clear, and return an empty list. Well, let's say, so obviously the most intuitive way to do this is just to return an empty list, because that's all it asks for. So this is basically clearing it, right? So what you shouldn't do though, please don't try to be cute and say, hey, I'm gonna iterate through this list and I'm gonna remove every element. So you might think that this is a pretty smart idea, you know? I can list.remove the item while I iterate through the list. This is a terrible idea. So if I return the list now, watch what happens. So let's say, so I'm going to interactively do this so that we can see what exactly happens. So let's say I have a list one of up to 8. 7, 8. So my new list now is going to be, it should be cleared, okay? So actually I'm going to name this cleared, okay? Cleared, I just call crazy, clear, oops, on my list, okay? So this should clear it, but let's see what cleared is. It's 2, 4, 6, 8. Huh. Somehow this crazy stuff happened. So let's try again. Try again is going to be equal to crazy clear on the list. So I'm gonna try clear the cleared list. So let's see what happens. Try again. Now we get 4, 8. So obviously it's not really doing the job. So the reason this happens is actually it has a little bit to do with how a for loop is implemented, which is something I'll talk about later in the course. But just as a general rule, never, ever, ever iterate through a list while removing it. Some really weird stuff will happen. So you would expect that this removes every single item in the list, but it doesn't.